Radical operations. First operation we're going to look at is adding and subtracting radicals. First thing you need to do is simplify. This is the opposite of everything we've done so far. First step is to simplify. Usually we simplify at the end. Here you want to simplify first. Next, do they have the same index or roots and radicand? Now what I mean is x plus x squared. Can you add these together? No, they're not like terms, right? So likewise, square root of 3 and cube root of 3 are not the same, are they? No. They have different roots or index. So these cannot be added together. And if you have a square root of 2 plus the square root of 3, you cannot add these together because the radicands in the middle are different. The only thing you can add together is like this example, 3 square root of 5 plus 4 square root of 5. Like terms. Think of this as 3x plus 4x gets you what? 7x. But in the case of x, it's a square root of 5. So how you add is you add the coefficients in front. 3 plus 4, 7. And keep the radical the same, square root of 5. Look at this example here. So one of these is not like the other. 2 times square root of 7 plus 5 square root of 3 minus 4 square root of 3. Which one is not like? This one, right? I cannot add this square root of 7 to these square roots of 3's. But I can focus on these and add them together. Again, we just want to look at the coefficients. So 5 and a negative 4. Add those together gives me a 1. So this simplifies to, or adds to, square root of 3. Again, I cannot do anything with this. It's not like terms, so I just keep it on the outside. So my solution is 2 square root of 7 plus square root of 3. Here, can I add these two together?
Yes, because it has the 7 are the same.
The 7 are the same, and can I add them now? No. So the 7's the same, the radicand, and also the powers are the same. So I can add them. So now let me take, negative 3, add that to 4, square root of 7 gives me what? Just a square root of 7. 54. But what was my very first step? What did I say you have to do first? Simplify. So let's simplify and then see what happens. So 2 square root of 6, well that's already simplified, right? Nothing I can do there. Now let me simplify square root of 54. So that breaks down into, let's see, 2 goes into 54 how many times? That would be a 27. 2 does not go into 27, but 3 goes into 27, 9 times, and 9 is 3 times 3. Now, what am I circling? What am I looking for? Pairs, right? A pair of 3's that's going to come out. So that gives me 3 times 3 is 9. Square root of, what did I not circle? 2 times 3 is 6. Now, when I look at the 2, can I add them together? Yeah, so that's why you have to simplify first, because they actually could be like terms. And that's going to give me 9 plus 2, 11 square roots of 6. Okay. 3 square root of 18 plus 3 square root of 8 minus square root of 24. As they are, can I add them or subtract them together? No. But our first step, we have to simplify. So negative 3, let me simplify 18. So does 2 go in 18? 9 times, right? And 9 is 3 times 3. So what am I circling? The 3's. So a 3 comes out. That gives me negative 9 square root of 2. I did not circle a 2. This next one, I have a 3 on the outside, and I multiply that 2. 2 goes into 8 4 times, and 4 is 2 times 2. So what am I circling here? One pair of 2's. That comes out. 3 times 2 is 6.
Oh, wait,
Yeah, you multiply.
Sorry, yeah.
6 times the square root of 2. So looking at these two, can I add them together? Yes. Now let's look at this one. So I have a negative square root of 24. 2 goes into 24 12 times. 2 goes into 12 6 times. 2 goes into 6 3 times. And 3 is prime. So what number comes out?
The twos.
I'm going to circle the pair of 2's. A 2 comes out. And so that leaves me with
Negative two.
negative 2 square root of?
6.
Very good. 2 times 3 that I did not circle is a 6. So could you add all of them together?
No,
No.
you can't.
One of these is not like the other. This one, right?
Mm-hmm.
I have to leave this one out of it. So it stays as a negative 2 square root of 6. And what about my square root of 2's? What are those turned into? Negative 9 plus 6 is a negative 3 square root of 2. Now note, the calculator can again help you verify your answer. So you can plug this whole thing here into the calculator. It's going to give you some decimal.
Hey, how did it turn to the next? Oh, it turned to the negative because the negative was already in the beginning of it?
Yeah.
Yeah, okay.
So I can plug this whole thing into my calculator. It's going to give me some decimal. And also plug this answer here in the calculator, and you should get the exact same decimal. That'll help you check your answer. So that's adding and subtracting. Simplify. Make sure they have the same power and the same radicand, and then you can add them together. Just add the coefficients. Multiplying may be a little bit easier. Multiplying, the first step is, do they have the same power? That's all I want to check. So a square root of 2 times the square root of 3 is okay, as long as they have the same power. Yet a square root of 2 times a cube root of 3 is not okay, because they had different powers. So as long as they have the same power, you can multiply them together. I'm not worrying about the radicands this time. How you want to multiply is multiply the coefficients, so the number on the outside, and then the radicands, the numbers on the inside together.
Right, down right foot.
So notice here, how do you multiply radicals? We'll multiply the insides together under one radical. And then you want to simplify. Don't simplify first, because you'll just give yourself more work. You'll have to simplify at the end. Yeah, this one is a little bit easier, I think, multiplying. Some of you may want to choose to do this in your rap, poem, comic, or short story.
Go back. All right.
You know, I do upload all the notes into Schoology at the end of the day.
Yeah, I don't want to make sure on paper.
Okay.
All right, I'm good.
Okay? So let's take this example. 2 times square root of 5 times 7 square root of 3. Do they have the same power?
Yes.
Yeah, square root, so I'm okay. Now when I multiply, let me look at the numbers on the outside. So 2 times 7 is 14. And then multiply the numbers on the inside. 5 times 3, 15.
No.
Fortunately, we didn't have to simplify it, so I'm done. 14 square root of 15. And again, you can multiply this in your calculator.
You just multiply.
Multiply this in the calculator. Yeah, you just multiply.
But after that, you simplify. Well,
And then you're going to simplify it, which we'll see with these examples here. Can I multiply these two together?
Yes.
Can I multiply these two together?
No.
No.
No. So I'm going to get rid of that cube to make them like terms. So I want to multiply the inside. So 5 times 10 is square root of 50. Now I need to simplify. So let's start with, does 2 go into 50?
No. Wait, yeah.
Yeah.
It does.
How many times? 25. What's half of 50? 25. 25 is 5 times 5. So how does that simplify?
Oh, you circle the 2 5?
Mm-hmm.
Yeah, you circle the 2 and you put them in the front.
Okay.
Right?
So
So
five.
it's
5 and over 2.
5 over 2.
Over 2, square root of 2. Don't say over 2, that's fraction.
Where?
Square root of 2.
Where?
Where what?
All gonna be the same though, like 5 over 2 and
5 over 2
It's
is
different.
not equal to
It's rooted over it.
whatever.
It's different.
It is different.
5 rooted over 2.
I know what you mean. You're putting something over 2. You're putting the radical symbol. How about this one? Negative 4 square root of 15 times negative square root of 3. Can I multiply them?
Can you?
Yes, you
Can I add them?
can.
No, but I can multiply them. Square root, it's the same. So now let me take the coefficients out in front. Change this to purple. So a negative 4 and a negative 1 and multiply it. So negative 4 times negative 1 is a 4. Now let me look at the radicands, the number inside, and multiply those. What is 15 times 3? 45. So 4 times square root of 45. I'm not quite done yet. I need to simplify. So 4 times square root of 45. Does 5 go into 45? How many times? 45 divided by 5 is? 9. And 9 is 3 times 3. So what comes out? Very good. 2 3s gives me a 3 here. So 4 times 3 is 12. Square roots of? Very good. 5. 12 square root of 5. All right. Now don't get discouraged. Don't get intimidated. It's not that difficult, just more work. You will see multiplication problems like this. Again, when you see problems like this, you should think of foiling, should think of distributing, which means take this first number, needs to be multiplied by each of these two. Second number, multiplied by each of these two. So one at a time. This is actually testing you with both multiplying and adding and subtracting all in one problem. So negative 2 square root of 3, multiply that to the square root of 3. Right here. So negative 2 times 1 is negative 2. Square root of 3 times 3 is 9. But what's the square root of 9?
Square root of 9, 3.
It's 3.
Yeah.
Negative 2 times 3 is negative 6. You should have seen that property in algebra 2. Square root of 4 times square root of 4 is what?
Square root of 4 times square root of 4.
Is the square root of 16,
Oh, wait.
which is?
Multiplying. Oh.
Well, multiplying. It's
I thought you were adding.
4. You'll start seeing the pattern. Square root of 5 times square root of 5 is? 5. Square root of 25 is 5. Square root of 7x times square root of 7x is? 7x. Yes.
It's like repeating itself.
Well, what you're doing is you're taking a root, that's the opposite of squaring, and you're squaring it. So the opposite of an opposite is the original. You should have seen that in algebra. We'll see that again when we do this function composition. Putting a function inside of its inverse gives you the x value, or the same value. Now let's go back. Negative 2 square root of 3 times this other number, negative 5. Look at the coefficients. Negative 2 times negative 5 is a 10 square root of 3. That takes care of this. Now I need to multiply this by each of these. 2 times square root of 3 is just square root of 3. And 2 times negative 5 is negative 10. Now, like we have been doing at this point, is combining like terms. You can add these together up, right? Same power, same root, same radicand.
12.
10 plus 2 is 12 square roots of 3. And then negative 6 plus the negative 10, negative 16. All right, let me demonstrate that.
Probably not that hard.
Let me demonstrate. 5 times negative 2. 5 times negative 2, negative 10. There's the first one. 5 times square root of 5 is what? Well, that's just 5 square root of 5. That wasn't too bad. Now let's look at negative 4 square root of 5 and multiply that by a negative 2. So negative 4 square root of 5 times a negative 2. Look at my coefficients. What's negative 4 times negative 2? 8 square roots of 5.
You was going fast.
What's that?
You write it down, you was going fast.
Or do you see how I'm getting these numbers?
Yeah.
No? 5, negative 2, negative 10, 5, square root of 5. It's just 5 square root of 5.
You gotta make sure you put the minus.
Yeah. Negative 4 square root of 5, negative 2. Multiply our coefficients is a positive 8 square root of 5. Oops. And then last but not least, negative 4 square root of 5 times the square root of 5. So we're going to square our radicals here. What is the square root of 5 times the square root of 5?
5.
Very good. So it's the square root of 25, which is what? 5. Right? Multiply the insides, gives me 25. Square root of 25 is 5. So that ends up being negative 4 times 5, which is negative
Oh, like I think we was gonna pick.
20. What's that?
Like I think we was gonna pick 5. Let's go with 5.
The 5 and the square root of 5?
No, not that. Like if you go back a slide, I think when we were doing it.
Oh, yeah, up here. That's what happens. Now I just need to combine my like terms. Can I add my square roots of 5s together?
Yes.
Yes, and I get what? 13 square root of 5. And what about my numbers? Negative 10 and then negative 20. Negative 30. Oh, no. You're right. This is not 15. That's square root of 5. Good catch. You try. Something funny happens here. The answer comes out kind of weird. So give it a shot. Let's see. Negative square root of 4 times square root of 4 is what?
4.
Very good. Did we get this far? My first term is 4. Right?
Yeah.
Next, square root of 4 times 3 is 3 square roots of 4. Did we get that far? Okay. Now let me look at negative 3 and multiply that to square root of 4. So negative 3 square root of 4. And then last but not least, negative 3 times positive 3 is a negative 9. So there's all 4 of my terms. Now what happens when you add your square roots together?
Which one is the one?
3 square root of 4, negative 3 square root of 4.
Add them. So
You are, since it's 3,
you get 0.
You get 0.
Yeah.
What's 3 minus 3?
Negative. Wait, 3 minus 3 is negative. It's 0.
0. 0 times the square root of 4 is just going to be a 0. So those cancel. Now I'm left with numbers. What's 4 minus 9? Negative 5. And yeah, you can actually plug this in the calculator and it'll give you a negative 5. So yeah, this is one of those odd sorts. Remember our perfect square formula? If it happens to turn out like this, you just get a 5.
You started with the.
Wait, so the 4 and the negative 9, you would add it or multiply it?
You would add it.
Add it? Okay.
So when we get down here, we're adding our like terms. So 4 plus 3 square root of 4 minus 3 square root of 4 minus 9.
Wait, can you go back to what you did with those 3 square root 4s?
But that's
Here?
They come out to be 0.
Okay, how did I find the 3 square root of 4s?
How'd you get 0 from that?
How did I get 0 from that? So
3, 1,
So I can add them together, okay? Square root of 4, square root of 4, same numbers. So I'm looking at my coefficients I need to add. 3 minus 3 times square root of 4. What's 3 minus 3? That's 0 times square root of 4. Any number times 0 is 0.
You can think of it as it cancels out itself.
Yeah, you can also think of this as, what's 3x minus 3x? Cancels, right? So 3 square root of 4 minus 3 square root of 4 also cancels.